Hello, in this video we're going to script how we can use line traces to be able to determine where our static meshes need to be placed inside of our box component. So let's go ahead and jump right into our random prop placement blueprint. And we scripted through our for loop. Now we need to script our line traces. So let's right click and search for line trace by channel. Make sure you get the single line trace by channel, not the multi-line. So we're going to need to basically calculate the start and end point for where these line traces are going to be drawn. And what a line trace is just a line in 3D space that we're drawing, and anything that the line runs into we'll be able to get information about in our out-hit output. So we want our loop body to go right into our line trace. And we're going to actually right click and split the struct pins for both the start and the end. So the first thing we're going to do is figure out X and Y for start and end. And we actually want start X, end X to be the same and start Y, end Y to be the same, because what we're wanting to do is draw our line traces from the top to the bottom of the box, so that we're only going to actually place a static mesh in the level if it actually is inside the box, and also if our line hits something. So back in construction script, let's go ahead and get the X and Y coordinates figured out. So the first thing we need to do is go into our components, and we're actually going to grab our editor visual component. And right now it is actually at the origin point, or the root, I should say, for our blueprint. But we're using this so that if we need to adjust exactly how these lines are drawn at a later time, we can do that and have it be independent from where the blueprint is actually set inside of our level. So we need to get the world location for our editor visual billboard component. So search for world location. We need to get that. And then we're going to take this world location, and we're going to take one of our setup variables, which is our spawn volume extent. We're going to get a reference to that. And what we're going to do is we're going to get a node called random point in bounding box. And what this is going to do is grab a random point within a certain box. But we need to pass it an origin and a box extent. So we actually have an extent right here, and we have an origin and world space for our editor visual, which is at the middle of our bounding box. So this is going to be how we get our X and Y values. So if we split this struct pin, we can take our return value X, put it into start and into end. Same thing with Y. Because we really only care about the Z value being different, and that's because we want the lines to be drawn straight down from the top to the bottom of our bounding box, which is our spawn volume. So the Z value, those are going to take a little bit more calculating to figure out. So what we need to actually do is drag off of our get world location and actually break that vector apart to get its X, Y, and Z. Then we need to take our spawn volume extent. We're going to duplicate that reference because we need another reference to it. Drag that down here. So you take this extent, we're going to right click on it and split the struct pin. We're going to take this Z and we're going to divide it by another float. Actually, I'm going to divide it in half. And then once we've divided it in half, we're going to add this float plus float. We're going to add this half of our box extent's height to the world location for our editor visual. So what this is going to be is our starting Z value. So this is going to give us a Z value that's right at the top of our box extent, because the editor visual is right in the middle of our box extent, and then we're going to add its height, or half its height actually, so that we get right at the top. Now the ending, what we're wanting to do is to take this ending right here, and we're going to need to add this ending, add to it one of our settings variables, which is our line trace length. I'll actually go and grab and kind of put these up here where there's some room. Drag this over. So what this is doing is saying, okay, we know where our start point is. We're going to then make our end point by taking our line trace length and adding it here. Now our line trace length, if you'll recall, is actually negative, because we set the line trace length up over here, which is the Z box extents Z value times -1. So now that we have our start and end point for our line trace, we can now set our visibility channel, actually leave that set where it is rather, and we don't need to do trace complex, we don't need to ignore any actors, but we want our draw debug type, we want that to be for duration. That way we can see the line traces in the editor for a short duration of time so we can kind of see where those lines are all being drawn. Now the next thing we need to do, in addition to doing our line trace, is now if our line trace actually hits something, which our return value will return true for, so let's drag that into a branch. If this line trace hits something, that is when we actually want to draw an instance of our static mesh, or add an instance of our static mesh. So if this is true, we need to search for add instance, and we'll find add instance world space SM instances. That's what we want. Now we need to make sure this is a world space add instance, because if we drag out from out hit, which is this is the information we get from a line trace if it hits something, when we break this hit result apart, this location, which is what we're going to use to know where to put our instances, that is in world space because the line traces are in world space. So now that we have this add instance world space node, right click to break the world transform struct and drag location to location. Now we could be done here. However, the whole purpose of doing an instanced static mesh component is to be able to do hundreds of static meshes. And we don't want to do hundreds of static meshes and have them look all exactly the same. So what we actually want to do is take our rotator, our rotation here rather, right click it and say split struct pin. And then we're going to get a random rotator. We're going to right click and split this. And we're going to get a random yaw out of that. So this is going to give us a random yaw rotation. So this is actually going to rotate around the z-axis. Then what we're going to do is we need to randomly scale this, but we want to make it a uniform scale. So what we're going to do is get a random float in range. And I totally did not spell that right, but range, there we go. Random float in range. And let's say the max value is 1.0 and the minimum is 0.45. That's a good range. Now you could script these out to use variables that are editable, so you could adjust these in the editor. For time's sake, I'm not going to do that, but feel free to add that functionality yourself if you want to. Then we're going to drag this random float into our transform scale, and we're going to get this conversion node. This converts the float value into a vector 3, or a vector value. How that does that is the vector ends up being x, y, and z values all the same as this float. So this is a way for us to uniformly scale our instance randomly. So that's it. If we click compile and save, we've now made a blueprint that is going to create all of these instances. So let's go ahead and test this out. So go back into our park. Now we have this box, so we've already extended out here. And we don't have a mesh set though, so let's go ahead and set this static mesh. And we actually have a field scabious, or scabious it might be. This is a flower, so we can click that. And we only have one right here. We've added one flower over here. So we can see as we move this around, we're getting a bunch of these flowers. Well, we're not getting a bunch of flowers. What we're getting is a bunch of places where the flower would likely be. So what we actually want is, let's say 400 flowers. And there we are. There is 400 flowers. Now the really cool thing is, these are all now a single static mesh instance component, all drawing these. So we can actually drag this anywhere in the level, and we get all of these flowers just randomly popping in. Now the other cool thing we can do is, let's say we want to go ahead and add another one of these random prop placements over here, and let's adjust its area, make it a little wider, a little longer. Well, we don't need to make it taller. To kind of cover this area, let's go ahead and add more of these field scabulus and up this amount here to maybe 200. And there's some more, and then we can hold down Alt and drag this and put some more flowers over here. Now these red spots here, all those are all of the hits for the line traces, and we set that debug to duration so we can see them being drawn. Now if we go ahead and click play, we now have these flowers all over the place, and they are all rotated differently. They're all scaled differently from one another. So now it just looks like we have kind of a field of flowers. And we don't have it in the center section here because it is not inside of this these boxes. So that's actually going to be it for this entire course. I hope you really had an enjoyable time going through and learning about ConstructionScript and seeing all of the really amazing, cool things that you can do with it. So I hope that this is going to be very helpful for your projects in the future, and I hope you enjoyed it as much as I enjoyed teaching it. So thanks for watching.